The first step in our design process is the ask stage. Here we raise several questions, first and foremost being, how do we create a canoe out of concrete that meets the design criteria? This question ultimately boiled down to several smaller questions, including how do we create a mixture of concrete that is both strong enough to stay together and light enough to float? How do we make sure our canoe meets the design restrictions? And how do we create the shape of a canoe out of concrete? To answer these questions, we turn to the research phase. This phase consisted primarily of information taken from established canoe teams about their mixtures and suggestions. The most useful source we found was this one from the St. Kitts College of Engineering. This information allowed us to move on to the imagine phase. In our imagine phase, our first idea was to create a female mold of our canoe and pour pre-mixed concrete formula into it. However, suggestions we found in the research phase led us to determine that this solution had several drawbacks that we felt could be avoided. One major factor that influenced our final design was that while there are no limits on the aggregates that can be used, there is a budget limit, which effectively limits how many materials can be incorporated into the mixture.
Now, for the second half of the engineering design process, it starts with the plan phase. We created a model in SolidWorks with the dimensions that we needed to fit the requirements, the angles of each side, the amount of inches of each side, to give us an accurate representation of what our final model would look like. This helped us design our mold and design the canoe altogether. Next, we had to create the first prototype. Our first prototype, we didn't actually make the whole model. We just took a little bit of the foam that we used for the model, and we painted some of our first concrete solution onto it. This would allow us to test the concrete, test our solution, and test the ratio of the aggregates we used to see if it would hold up in water. We figured out with the test phase, which was next, that this solution would actually not hold up in water. It crumbled really easily, it had too much sand in it, and underwater it would just completely turn into muck. And so we realized we had to switch up the solution, add less sand and more of the other aggregates. So this brings us toward the next step of the process, which is improve. As you can see in this picture, we use the actual mold here after we cut out the styrofoam and mix up the mold, the solution to add less sand and more of the other aggregates. We painted this on there, let it dry, and it ended up sticking a lot better, and it looked a lot more like concrete. Unfortunately, when we tried to take out the mold, things cracked and it ended up crumbling, which is what we would learn to fix if we were to do this process again.
Hi, my name is Henry Conway, and I'm majoring in electrical engineering. In this video, I will be describing the project's functions and how well it meets the project description. So, our concrete canoe has one obvious function, and that is to float. To make that happen, we mixed a fertilizer called perlite in with our concrete mixture to help with the buoyancy. Whenever creating the mixture, we wanted to make sure enough perlite was being used to ensure it would float. Now let's move on to the dimensions and how we meet the project description. Next up is our CAD images. This is a drawing of our 3D model of our concrete canoe. The length of this canoe is 18 inches, the width is 6, and the height is 5. We decided on these dimensions as they meet the criteria for the project. The canoe is also modeled to have a V-shaped stern and a V-shaped bow. The bottom of the canoe has been rounded for looks, and both tips of the canoe have also been rounded. Other than those rounds, we have kept as many straight edges as possible to make the building process as simple as we could. The thickness of the canoe is 0.2 inches. This should be thick enough not to leak and also to make the canoe buoyant enough to float. Next is a video of how we applied the concrete and created our canoe. This is me using gloves to paste the concrete onto our mold. We found it easier to use our hands so we could get the perfect length around the entire model.
The main thing in our project that we would do differently is to give ourselves more time and to make more prototypes. We only gave ourselves enough time to make one prototype and it ended up failing, and so we were forced to present a crumbled up canoe. As far as procedures go, we would have put something like newspaper or wax paper around our mold to make removing the concrete easier. Another thing we would have done differently is instead of painting the concrete onto a mold, we would have poured it into a mold and pressed in the shape with another mold. This would ensure that our canoe would have had an even thickness all around, which is something our canoe didn't, and which is partly why it had failed.